Hello friends, today we are going to see about another topic called artificial neural network. Let's see what is artificial neural network. Artificial neural network um, is based for deep learning, and after after developing this artificial neural network, the deep learning the concept is come to place. This artificial neural network is based for all LLM models or any machine learning models that are developed by neural network. The base thing for that was this artificial neural network. Let's see the base structure of this artificial neural network. In an artificial neural network, there are three layers. There are three layers. First one is input layer, and second one is hidden layer, and third one is output layer. Okay, this first layer was called as input layer, input layer, and this middle layer is called as hidden layer, and the last one, the final layer was called as output layer. In input layer, the input data will be given to the first layer of an ANN. Let's take x1, x2, and x3 be the input. The final output is get from the final layer, that was y, and 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 in between every every layer there will be and weight will be there. This each section is called as neuron. This neuron is the neuron is it's like a human brain. Let's take this overall artificial neural network is work in a base concept of our human brain. In our human brain, there are so many neurons will be there. In each neuron, the information will be stored. Whenever whenever we're doing any action, the neuron will give the information. For example, whenever you're thinking, the the thinking things are stored in neuron. Whenever we do some action, that was controlled by our neurons in our brain. Like that, when this this each neuron will store the information that are get from the data which we have provided. This in between each neuron there will be some weight. There will be an weight. Inside this hidden layer. In hidden layer, the input layer have, there is in artificial neural network, there is only one input layer and only one output layer, but the hidden layer can be have one or more. For example, here I just given a single hidden layer, but in In most of the cases, there can be many hidden layers out there. There are like this. This one is input layer. This one is output layer. The in between in between these, there are so many hidden layers will be there. The input layer get the input and transfer to the transfers to the hidden layer, and hidden layer will understand the pattern of the data and structure of the data and store the information about the data inside it inside it, and depending upon that, the output will be provided. But how does the information will be stored? Let's see. Inside this hidden layer, there is an one neuron will here there is a neuron. Inside this neuron, there are two things will be happen. The first one is the step one is the incoming input data and this weight multiplied together and given to the hidden layer. After given to the hidden layer, the first step of given to the hidden layer of all of the neuron, each neuron will do two steps. The first steps will x summation of xi wi I equal to 1 to n number of input. This was the first step will happen inside a neuron. That means the x1 x2 multiply together, x1 and w1 is multiplied, and the x2 and w2 is multiplied, and the x3 and w3 is multiplied. This w is called as weight. Means weight. These are multiplied together and given to the neuron of a hidden layer. The hidden layer firstly summation this input, and with this there will be another value is called bias. We can see this bias later. Like this it will be add, and then after doing this there will be a second step that was after this summation, a sigmoid activation function will be applied. The activation function will be applied. There are so many activation functions are there. This activation function will define whether the neuron should need to activate or not. For example, here there are so many neurons are there. Each neuron will store some information, but the information is important or not, are defined by are defined by this activation function. For example, this is hidden layer. There are four neurons. This neuron is have some information. This neuron is have some information, and these four neurons have some information, but but this this information are important or not, that was decided by this activation function. Now, after applying this activation function, the activation function will define whether the should, whether the neuron should activate or not. Okay, this activation function here in this we are using sigmoid function. Sigmoid activation. There are so many activation functions outside. Or the sigmoid function, ReLU function, PReLU, and there are TANH. There are so many activation functions are there. But here, for 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 a basic example, we can take sigmoid function. The sigmoid activation function will give output from 0 to 1. If the neuron have a value of 0, then that then that neuron, the information that inside the neuron will not be considered, or it can be, we can be say that neuron is not activated very well. But when a neuron is having a value of 1, we give a high priority to the neuron and the information that have. And finally 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 calculating this, after calculating this function, this this output is given to the output layer, to the next layer. Here I take the here I take here I only use one hidden layer, so that the next is output layer. This output is, uh, for example, this neuron is giving a output of n1. This n1 and w4 is multiplied together and given to the output. In output, there will be there is also a neuron. The same thing will be happen. The same formula, the mathematical function will be happen in this output layer. Then after calculating this, the activation function will be applied. For example, where we are whenever we are doing binary classification, the output layer have use sigmoid activation function. The sigmoid activation function output will be 0 to 1. For example, um, let's consider we training the artificial neural network to decide whether the um, rain will come or not, depending upon the input data. Like the x1 will be temperature, and the x2 be the climatic condition. Climatic condition means whether it was sunny, uh, and the x3 will be the air condition. Depending upon this input, we need to decide whether rain will come or not. We should decide whether the rain will come or not. So come or not. For this, when the final output layer giving 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 output more than 0.5, let's take whenever the zero means there is no probability that rain come. The one will define it as there is high probability that rain will come. Whenever the final output value is greater than 0.5, we can consider this as the rain will come. Whenever the final output is less than 0.5, we can consider this as there is no rain at this moment. Okay, like this this uh, this artificial neural network will be work. The input data is taken and given to the input layer and flow through hidden layer and finally go to the output layer. the, this whole function is done in a forward manner. This overall tech flow, input flow is called feed forward forward network. Okay, whenever we training this neural network, for example, the output of the neuron is, let's assume as 0, but for this input the actual value is is 1, is 1. So that this overall ANN network does not train well, because for this input data the output should be 1, but this neuron give output as 0. That means the input the actual output and predicted output is not correct. So that we need to do back propagate. That means we need to, the weights are is not in a it's not properly trained, so we need to train it properly, then only it give the output correctly. So we do, first we we calculate, we apply loss function to the actual output and the predicted output. After calculating the cost function for both, we do back propagation. That called, we go we go back from output layer to hidden layers and we update the weight. This w1 have some value initially. Let's take the w1 having a value of 0.01 and w2 having a value of 0.03 and w3 having a value of 0.1. This w4 has value of 0. Value of 0.09, but our final output is not not equal to actual output. So the weights are not in a proper format, are not correct. So we back propagate and update the each weight. For example, um, the w4 is as an example 0.8. This w3 is can update as 0.15, and this w2 can update as 0.06, 0.63. Like this, uh, whenever the output, actual output and predicted output not same, a cost function will be calculated, and then doing back propagation, the each weight is updated, and and then then the feed forward calculation will be happen until this loop is do routine until we get the actual output. Like this only, an ANN will be work. This is the overall architecture. This forward moving of the forwardly updating the weight is called as feed forward network, and whenever we do backwardly and update the weight is called Backpropagation. Backpropagation. Whenever you update a weight in a forward manner, it was called as feed-forward network. Whenever we update a weight in a backward format from output to input, we updating the weight. Uh, this was called as backpropagation. This weight updation will be happen by using some chain rule. By this, it will update the weight. Um, Depending upon the data and their output, the output um, the output various activation function. For example, for a binary classification, um, whenever the cat or dog, it will be rain or not. Like whenever the uh, two state of output, whenever we are having a two state of output, we can use binary classification because whether it can be 0 or it can be 1. Like that means we having a output, we can use binary classification. Whenever we having a whenever we are having a multi-class classification, that means uh, multi-class classification means for example, we have a bank status data of a person. uh, we need to train the neural network whether this bank holding person, this bank holding person, what will be his civil score. It can be good, bad, or normal, or very bad. These kind of multi-classification, when the data is having, we need to use softmax function. The softmax function uses probability. The softmax function uh, will give this was used for multi-classification. Multi-classification. Okay, this was the overall architecture of an artificial neural network. We can see more further topics in upcoming classes. Thank you.